Happy Monday, guys. I went through and made an entire screen recording of this lesson, doing it all out, writing it all out, and for some reason it did not save. I have no idea where it disappeared to. So I'm just going to walk through it again. It was about 30 minutes, so I'm not going to redo it because that seems crazy, but you guys, I feel confident in the fact that you can work together and get through these notes and kind of pause where you need to pause. I'm going to walk you through it though. And then you guys are going to work on it together and then do math space. But it's distance formula and midpoint formula. And you guys have done both of these before. All right. You definitely did them in algebra. I know some of you didn't have the best experience in algebra, but that's okay. Because we're going to look at it again. But the distance between 2 points is just the difference in the two x values squared plus the difference in the two y values squared. All right, so you have two ordered pairs wherever they are on a coordinate plane, and you're going to find the distance between them. All right, for example, in this first question, find the distance between, if we plotted this out, and you don't have to plot it out, but let's just say -1, 9 is here, and -4, 1 is here. I don't know why I put it there. -4, 1 is here. We're looking for the distance between those 2 points. All right. And literally you are just applying the formula, which I will rewrite right here. Just applying this formula from here. So x2 minus x1 squared plus y2 minus y1 squared. All right. We've got our points right here. As you can see, I took x2 minus x1 and squared it, and then y2 minus y1 and then squared it. Notice, even if you get a negative on the inside, it's always going to end up being positive because a negative squared is a positive. You're going to most likely end up with the radical answer. It doesn't simplify. There's no perfect squares that divide into this. So I would kind of pause the video at this point. Make sure you're doing the algebra correctly. But basically, you are really just subtracting your x values from the ordered pair and squaring them, and then subtracting your y values from the ordered pair and squaring them. All right, and then the square root of the whole thing gives you the distance formula. So you might want to pause there and look through that example. All right, this is a kind of longer example that was so nice when I was walking through it, but I'll walk through it with you again. First of all, I plotted all of these points. All right, go through. Now my thing is not going to work. Go through and plot all those vertices. You'll notice that we have A is at -4, 3. B is at -2, -4. C is at 4, -4. And D is at 5, 3. All right, so you have all of your vertices. And we are looking for the perimeter, which is a distance around the outside edges. Okay. Actually, I'm going to go ahead and erase all this for you. I didn't really want to erase the figure, but I don't know. I guess we're starting over. What if I do that? I didn't really want to erase. I don't know, guys. I'm frustrated. I already did this once, and it's mysteriously vanished. I don't know where it went. You guys know. Anyway, all right. I'm not going to erase it. But the point is, if you have a flat side like A to D, you can literally just count the spaces like 1, 2, 3, 4, 5, 6, 7, 8, 9. So the distance between A and D is 9. You can also get that by subtracting the x values, -4 minus 5, and taking the absolute value. I think it's easier to just count them. The distance from B to C down here is 6. All right, those horizontal lines are very easy to find the distance, so you just can count the spots. Now, when you are taking the distance of the diagonal sides, you're going to have to use the distance formula. So for C to D, which is over here, you're going to look at points C and D, and you're going to subtract the x values, so 5 minus 4 squared and 3 minus -4 squared, and you're going to simplify it, and you end up with square root of 50, which actually does break down into 5 root 2. But you're going to be able to use a calculator for this, but it's just good to know that's what we have. So the distance on this side was 5 square roots of 2. All right. And then if you look at your distance of AB, which is over here, you're going to do the same thing. A and B, you're going to subtract your x values and subtract your y values, square them, and end up with the square root of 53, which is where this comes from. All right, again, I would be pausing some as you're going through this. Find some people you work well with. Make sure you know what's going on. All right. And then you add up every side to get the perimeter. And you cannot add those together because they do not have like bases, but we could put that in our calculator and get 29.35 units. All right, part 2 asks to find the area of the quadrilateral, and the area is the inside space. So as you'll notice, I broke this into 1, 2, and 3 sections. There's 2 triangles and a rectangle. So this first triangle, triangle number 1, has a base of 2 and a height of 7. All right, so it's just 1/2 base times height to give us 7. And then part 2 is this rectangle, and it has a base of 6 and a height of 7. 6, 7, that's so bad. Okay, anyway, and you get 42. That just occurred to me. And then part 3 has a little teeny tiny base here of 1, and then its height is also 7. And the base and the height are the non-hypotenuse sides, okay? They are the straight sides, not the diagonal side. So base, height comes from Pythagorean theorem, all right? And then you get all of your individual areas, add them all up, and this is what you get. Okay, we're looking at area of triangles. If it's a right triangle, the area is 1/2 base times height. The next part of this lesson is midpoint. So if you have a line segment, if you're looking up here, you have a line segment. We learned that the midpoint, in this case B, will divide section AC into 2 equal parts, AB and BC. And this was on the last test. B is the middle. And in order to find the middle, you're basically taking the average of the x values and the average of the y values, okay? And that means I'm adding up the x values and dividing by 2. I'm adding up the y values and dividing by 2. All right, the average is the middle, and if you have 2 points, it's the center of the middle. All right, so your x, m, y, m are the coordinates of the midpoint, and then you have 2 endpoints. All right, so if we had a line segment with -5, 12, which is here, and 10, -4, which is here, and we're looking for the midpoint, you're just going to take the x values, -5 and 10, and divide them by 2, and then the y values, 12 and -4, and divide those by 2, and simplify. And you notice you get 5 halves, which is 2.5 and 4. And if you look at the plot, this is at 5 halves and 4. So you know you've done it right. It helps sometimes to have a visual. You can kind of look and see what you're doing. I think that's super helpful. Sometimes you're given the midpoint and you need to find one of the endpoints. Notice point B is just A comma B. So writing everything out, again, if we're looking at just the x value of the midpoint, we know that it's going to be equal to x1 plus x2 divided by 2. So take the x value of the midpoint. We know that the x value of the midpoint, I'm going to redo this because this does look confusing. I believe now that it's got all this stuff written on it. I'll just redo this part for you. If I plug in the x value of the midpoint, it happens to be 9. It's right here. It's highlighted right there. So 9 is going to equal x1 plus x2 divided by 2. And to solve that, you can multiply both sides by 2 or also cross multiply. What happens over here is they cancel out. So you're left with 18 equals 1 plus a, or 17 equals a. All right. You're going to do the same thing with the y values. You know that the midpoint of the y value is 7, and we've got 4 plus b divided by 2. I realize it's only asking for the value of a, but we might as well find the whole coordinate pair. Cross multiply or multiply both sides by 2. You get 14 equals 4 plus b, or b equals 10. All right, so your end point that was missing, point B, is 17 comma 10. All right. So, and if you kind of drew that out very roughly on a coordinate scale, if A is at 1, 4, and B is at 17, 10, let's just say that was like here, the midpoint should be at 9, 7, and it would be. That looks about right. Okay? Because if you checked it, 1 plus 17 divided by 2 is 9, and 4 plus 10 divided by 2 is 7. So you can always check it by sketching it out when you're done and seeing what happens. But the coordinate that was missing that we solved for was this. All right, I'm not sure why these definitions came after the fact, but the perimeter is the distance around an object, and the area is the amount of space inside a two-dimensional shape. Area of a rectangle or a square is just length times width, and the area of a triangle is 1/2 base times height. And it has to be the perpendicular. Remember, it has to be the straight sides. So this is the height and base, and then height. The height and the base will form right angles. So 1/2 base times height. So I kind of went through this, and to find the perimeter of this shape, you can really just count and label all the edges. Like from here to here is 2 spots. So I put a 2 here. From here to here to here to here is 4 spots. So go ahead, and if you count all the sides, this whole length is 8. There are 8 spots. 2, 3, 4, 5, 6, 7, 8. There are 8 spots across the top. And the perimeter is the distance of the outside edges. The one thing you need to find is the distance between these 2 points, because it's on a diagonal and we didn't have it. So the distance between these 2 points is square root of 41. It's done through the distance formula here. So you probably want to pause and take a minute and kind of do that. And then you add everything around the shape to get the perimeter. And I didn't have a calculator right next to me, but 21 plus square roots of 41. You could put this in your calculator and get a decimal answer. And then like we did previously, the area, I broke it into 3 parts that I could know the area of: a right triangle, a square, and a rectangle, and then find the area of each shape. All right, so this is another example. Similarly, I went ahead and found the midpoint to make sure that the midpoint was in the middle as it looks, and that I can find the height. And then I had to do a distance formula here. So I want you guys to kind of go through and see if you can calculate the area of the triangle here. Or if you have a better way to calculate the area of a triangle. Maybe you have a better way to calculate the area of a triangle by, you know, maybe you add some lines on the outside and find the area of this space. Find the area of this space, and then find the area of this space, and the area of the whole thing, and you could subtract those, and you'd have what's left. So that's a way to do it too. Like you could find the area of each of those and the whole thing, and subtract out the individual red parts, and see if you end up with 26 when you're done. Check that out. That might work too. Just something to do. All right, so you guys are working together, I hope, finding a group that you're working well with and you're not messing around today. I'm going to be very disappointed if I don't get a good report when I come back. This problem you already did previously, but you know what? If you want to do it again just to make sure you did it correctly the first time, then go for it. And then there's a math space, all right? And if you're totally lost, please come see me Tuesday during Mustang Block, and I would love to go over this with you. But hopefully it's going to go okay. All right, I'll see you guys soon. Bye.